Good morning, dear students of class 7. So, last class we came to know about metals, non-metals, metalloids and noble gases. So, the last class I said you elements are broadly classified into 4 groups. They are metals, non-metals, metalloids and noble gases. Metals have the tendency to lose electron and hence can form cation. Non-metals have the tendency to gain electrons, hence can have negative charge and can be an ion. Now, today we'll be comparing, we'll go for the properties, comparative study. Means today we'll be knowing about the difference between metals and non-metals in their properties. Difference in metals and non-metals in their properties. So, what is the difference between metal and non-metal on the basis of their properties? We'll come to know today. We'll learn today. So, let's see now. Color. Metals are generally silver or grey. Silver or grey. Metals usually have silver or grey color. Gold and copper are the only exceptions. That means if you happen to cut iron, the freshly cut portion will be silver in color. If you cut aluminium, the freshly cut portion will be silver in color. If you cut silver itself, then the freshly cut portion will be silver in color. And you have seen mercury is also silver in color. So, basically all metals are either silver or grey. Zinc is grey in color. So, lead is also some grey in color. So, basically metals are grey or silver in color, except copper and gold. Then what is the color in copper and gold? So, copper is reddish brown in color. Copper is reddish brown in color. If you happen to cut the wire, electrical wire through a knife, using a knife, then freshly cut portion, you can see it is shining reddish brown in color. So it has reddish brown color, copper. And gold, you have seen, it is yellow in color. So these are 2 exceptions. So this is very important. You need to learn the rest of the metals are silver or grey color, but copper is reddish brown in color and gold is yellow. Gold is yellow in color. Okay. But non-metals, you have seen many non-metals. So basically you have seen carbon. So carbon is dark, it does not have that nice color, so they are dull. So how they are separate means how metals are different. How metals are different from non-metals? With respect to this color, metals have a particular color, a shining color. Non-metals are dull. Then hardness. Metals are generally hard. And it is very tough. It is very difficult to cut them. We cannot cut metals very easily. Can you cut iron very easily? No. Can you cut aluminium very easily? No. So, we cannot cut metals very easily because they are very hard. But there are also exceptions. Some metals are so soft. Some metals, okay? Generally, all metals are hard. But there are few exceptions. There are few metals which are soft. Okay? And some of the soft metals which can be cut with knife are sodium, potassium. These are very, very soft metals which can be cut with a knife. Okay, so these are the exceptions. My dear students, what is very important here is you need to know exceptions. You need to know exceptions. So in color also, two metals, copper and gold, have exceptional color. In hardness also, sodium, potassium has exception. The exception means they are not hard, they are very soft. They are very soft. Non-metals are soft. Non-metals are soft. But again, in non-metals also there is exception. There is exception. So non-metals. In non-metals also, one form of carbon, that is diamond. You are very much familiar with the word, with the thing, with the substance diamond. So diamond is carbon. Diamond is carbon. But diamond is the hardest substance known. So being non-metal, diamond is very hard. Rest of other non-metals are soft. Rest of all non-metals are soft. Let me repeat it again. Regarding hardness, metals are hard, non-metals are soft. Metals are hard, non-metals are soft. In metals, there are few metals which are soft. They are sodium and potassium, which can be cut with knife. So, which are the two metals which can be cut with the knife? Sodium and potassium. And non-metals are soft. But diamond is the exception. Diamond is the hardest substance known. So which is the non-metal which is very hard, or named the hardest non-metal? Then that is diamond. So regarding this hardness also, metals and non-metals are different. So non-metals are soft and metals are hard, leaving the exceptions. Then comes luster, means shiny appearance. Shiny appearance. You can see gold. The fresh gold, golden jewelry is shining. Okay. And though the iron is rusted, though the iron is very old, but if you happen to cut this iron, then the freshly cut portion shines in silver color. Shines in silver color. So metals have this shining appearance. Metals have this shiny appearance. And this shiny appearance, the property by virtue of which a metal shows shiny appearance, it's called its luster. It's called luster. So what is luster? It is the property of a metal because of which the freshly cut portion shines. Okay, S-H-I-N-E-S, shines, is luster. So metals are lustrous. Metals are lustrous. All the metals, if you happen to cut, then they show shiny appearance. But non-metals are non-lustrous. They do not have the shiny appearance. If you happen to cut, if you happen to break charcoal, does it shine? No, you will not get the shine. Okay, if you happen to means most of the non-metals are gases, few are solid. So all the solid also basically is carbon is solid, iodine is solid. But iodine exception is there again in luster also. Iodine and graphite being non-metal, graphite is a form of carbon, being non-metal has a shiny appearance. So, one may ask you a question, name two non-metals which are lustrous. Name two non-metals which are lustrous. Then you can say these are iodine and graphite. Graphite, one form of carbon, are lustrous. Rest of all the non-metals are non-lustrous, but all metals are lustrous. All metals are lustrous. So, because of the shiny appearance, metals can be used in jewelry and decorations. Otherwise, there is no need of using metals in jewelry and decorations. So, why metals are used in jewelry and decorations? It is because of their luster. It is because of their lustrous property they are used. Then comes malleability. Malleability is the property of metal by virtue of which it can be beaten into thin sheets. You have plates of metal, aluminium plate, brass and bronze plate, then you have steel plate, you have aluminium plate, so you have aluminium coin. So they can be beaten into thin sheets, and you have seen this one, aluminium sheets also. So they can be beaten into thin sheets. If you keep iron, a small iron bar on the railway track, and if you allow this one train to pass through this iron, then later on you can see that it will turn into thin sheets. If you happen to beat this one iron nail with hammer, you can see it will spread into thin sheet. So this property of metal, by virtue of which they can be beaten into thin sheet, is called malleability. And the substances which shows this property of malleability are said to be called as malleable. So metals are malleable. Metals are malleable. Non-metals are non-malleable. If you happen to hammer carbon, it will break into pieces, but you will not get a long thin sheet. So malleability, that means metals are malleable, non-metals are non-malleable. They cannot be beaten into thin sheets. Okay, and metals are malleable. There are also some exceptions. Zinc is brittle, it cannot be beaten into thin sheet. Zinc, name the metal which is non-malleable, then you can say it is zinc, because zinc is brittle. If you start beating it, it will break, but you will not get thin sheet. So, regarding the activity to demonstrate malleability in metals, so what are the materials required? A hammer, an iron nail, a coal piece, aluminium wire, and a pencil lead. So materials, we got a hammer, we need a hammer, then the things we need are an iron nail, a coal piece, aluminium wire, and a pencil lead. So iron is metal, that means iron nail is a metal. Coal piece is a non-metal because coal contains carbon and carbon is non-metal. Then aluminium wire is a metal. Then pencil lead. Pencil lead is also carbon, it is made up of graphite. Pencil lead is made up of graphite. So graphite is lustrous, but it is not malleable. Graphite, being non-metal, is lustrous, but it is not malleable. So take an iron nail, a coal piece, aluminium wire, and pencil lead. With each of these objects with a hammer, take care that you do not hurt yourself in the process. Observation: on beating the iron nail and aluminium wire, they convert into thin sheet, while coal and pencil lead break when hammered, because pencil lead and coal are non-metals and non-metals are non-malleable. Iron and aluminium are metals and are beaten into thin sheet without breaking. However, coal and pencil lead, that is graphite, are made of carbon, a non-metal which breaks when hammered. These shows metals are malleable while non-metals are non-malleable. So, again, let me repeat it again. Color. Regarding color, metals are colorful, non-metals are dull. Metals are colorful, non-metals are dull. Then regarding hardness, metals are hard, non-metals are soft. Some exceptions are there, but generally metals are hard and non-metals are soft. Then regarding this one, regarding luster, metals are lustrous, non-metals are non-lustrous. Metals are malleable, non-metals are non-malleable. And regarding ductility, so what is ductility? Ductility is the property of metals by virtue of which it can be drawn into thin wires. You can see copper wire, you can see iron wire, okay? Then you can see aluminium wire, but you cannot see wire of carbon. You cannot see wire of carbon. You cannot see wire of oxygen. You cannot see wire of nitrogen. So, again, metals are ductile, non-metals are non-ductile. They cannot be drawn into thin wires. So, this much for today. Hope you will study at home. Hope you are studying and doing your work. So, thank you.